Hello, I'm Rukiye. I'm very excited to present the third edition of the Predicting Media Memorability task this year. This is the first time that we are a part of the organization of the task from the University of Essex. We have a great team that has been also working on the task for past 2 years. The goal of the Predicting Media Memorability task is predicting how memorable a video is to viewers. This task requires participants to design systems that automatically predict short-term and long-term memorability scores for videos. This year, we wanted to include more actions in dynamic videos with not only using visual but also audio features. Therefore, we collected memorability annotations on TRECVid 2019 video-to-text datasets, which provides also human annotated captions for each video. Similar to the previous editions of the task, memorability has been measured twice. For short-term memorability, memorability is measured after a few minutes, and for long-term memorability, from 24 hours to 72 hours. To collect annotations, we used video memorability game, which is proposed and used last year by Romain and Claire-Hélène's team. We modified the code and shared two versions of the game, one for Amazon workers and one for volunteer participants. In the game, the task is basically to press spacebar when the participant recognize a previously seen video, so we can determine whether videos are recognized correctly or not. If you like, you can visit the link and contribute to data collection. In the first step of the game, 40 targets videos are repeated after a few minutes to collect short-term memorability labels. 20 of the fillers are also repeated to check participants' attention to the task. After 24 hours to 72 hours, the same participants are expected to attend the second step for collecting long-term memorability labels this time. 40 targets videos are chosen randomly from non-repeated fillers of the first step, and 80 fillers are also displayed, chosen from totally new videos. TRECVid 2019 dataset is composed of 6,000 videos, but it was not possible for us to annotate all videos, so we selected only 1,500 videos having more annotations. Firstly, we released 590 videos and updated it with 410 more training video samples. We evaluated submissions on 500 test sets. There are many types of in the data set, such as football, basketball, concert scenes, and funny videos from social media. You can see here there are big differences between the different types of videos. So we really want to know what makes the difference and what makes a video memorable. Like the previous editions, we shared pre-computed features. This time there are 2 to 6 human annotated captions for each video. We also shared annotations with response time, key press, and video position, where the video is remembered or not remembered. Ground truth, short-term and long-term memorability scores are also shared on training set by calculating as the percentage of correct recognition for each video by the participants. Here is an example video with low short-term and long-term memorability score, and you can also see 5 text captions for this video. Here is another example with high short-term and long-term memorability scores. There are two available text captions for this video. So far, we have 19 participating in this year and total 28 runs submitted. We have 8 contributions where we can learn more techniques for the current task. This is the first time we have shared real-world complex video data with audio. Therefore, the results achieved in this year are quite low, considering the mean and the variance of the results gained by all the participants. This table summarized official results on test set for all submissions. We highlighted the highest scores in red and bold black. Official results on test set for the team's best runs are also presented on this table with used approach. Very interesting methods have been submitted by participants where audio, textual, and visual features used. Audio features and embeddings are really interesting this year. A variety of regressors have been explored on the datasets. And again, Momento 10K datasets attracted in a few submissions. The same table for the long-term subtask by the same teams with their used approach are presented here. After a few minutes, we will learn about how participants were teaching the computers using those methods to predict memorability scores. As for conclusion, short-term memorability scores are higher than long-term, but no big difference between both tasks. As I showed the slides before, the highest correlations found by teams DCU Audio, MG-UCB, and MIMAT. Audio and captions improve the results, and also using feature fusion or late fusion techniques can help to get better feature representations. Also, deep learning techniques can enhance the performance. As I mentioned before, this is the first time we have shared real-world complex video data, and we had difficulty in collecting annotations because of the current global problem. In the future, we plan to collect more annotations and share more video samples. Thank you very much.